Am I audible to everyone? Am I audible to everyone?
Yes, sir.
Okay.
Yes, sir.
So very good morning, good afternoon. We will be looking the remaining part. Okay. So last time we have done with the different rules. That is called as a COTS 12 rule. We have seen, I think, 7 rules we have done. We have to go with the remaining rules. My screen is visible now.
Yes, sir.
Okay. Okay. Yes. So we were talking about the chords rule. Okay, so today we'll be completing the remaining chords rule, and then we can proceed to the other part. So in the chords rule, I have told you, I will just revise quickly. The chords rule, we have seen that this is also called as a chords 12 rule because the rules are from 0 to 12. So total 13 rules are there. Okay, and these rules are, these are the concepts. Okay, to test the DBMS. Okay, whether it qualifies for the relational model, that is called as the RDBMS. Okay, so this rule actually defines what quality a DBMS requires in order to become a RDBMS. So rule 0 talks about the fundamental that is also called as a foundation rule or base rule. This rule states that for a system to qualify as an RDBMS, it must be able to manage database entirely through the relational capabilities. Okay, so we should have the different table. So in that table, you should have the the different attributes should be there. There should be tuples. The domain should be there. So it should have a rows and columns with the name, the table name. So that is a foundation that is most important to qualify for the RDBMS. So that is a basic requirement. That is a basic requirement to become an RDBMS. अगर table format में नहीं है, then you cannot qualify for RDBMS. Okay, so relational capabilities you should follow. Am I audible to everyone?
Yes, sir.
Huh. See, please correlate what with what you have written. Okay, I will be just going through this particular rules. You have to see whether what you have written, and you have to just revise. Okay. Then rule 1 says about the information rule. Now this information is to be presented as stored data in cells of tables. Okay, that means the rows and columns to be strictly followed, and it should also include the metadata. So we have talked about the metadata, that the data about the data, so that thing also can be included in the table to qualify for the RDBMS. So that is the information rule. So information about the data about the data can be included to form a RDBMS. Then rule 2 says about the guaranteed access. This is also important, that if you have to have access about the any see we if you want to have an access, it should be in the form of a query, and the query is through the SQL. Okay, structured query language. So if any query is there, if you want to access any of the data, that should be accessible by using the table name, the primary key. See here, primary key means the row, and the attribute, that is a column. Okay, I have given an example to understand this concept of guaranteed access. Then comes the rule number 3, that is the systematic treatment of null. Here I have told you what do you mean by null. Null doesn't mean it is a zero value. That is very important. The null here implies the missing data, or there is no value, or it is not applicable, or at present we do not have the information about that particular attribute. In future it may be available. So in those cases we can have a null value. Okay, we should not be able to put zero as a the value. It should be put as a null, null. Okay, then also about this we have written that the primary key should not be null. Okay, it should not be null. The null value must be independent of data type. That means your null value should be independent of data type. You can put null value for the string, you can put the null value for any integer, whatever. So it should be independent of the data type. Then comes the rule 4, that is active online catalog. So your catalog is about your database dictionary. Okay, it is actually the description of about the the complete database, that how many attributes you have used, how many tuples you have used, how they are correlated with each other. So all these information should be available or should be stored online on the catalog, and this catalog should be governed by the same rule as rest of the database. Yeah, the same query language should be used on the catalog as used to query database. Okay, so if I'm using a specific language SQL, so the same query language should be used for the catalog, to access the catalog, as we are using to query the database. That is the meaning for rule number 4, that is active online catalog. Then comes your rule number 5. Rule 5, powerful and well structured language. Yes, so the your Oracle, as I have told you, has the SQL. So whenever you have to manage or you have to access any data which is stored in the database, that should be managed by the structured language only. Okay, if you take any of the language, that language should be able to access the data. Okay, so in that so we have written, if the database allows access to the data without the use of this language, then that is the violation. Okay, it should not happen that you are accessing the data without using the structured language. No, that means you are violating this rule number 4. It should be always through the language. Okay, and remember the important is the query language, that is SQL. Then I think we have talked about the rule 6, that is view updation rule. Yes, this is also important. All the view that are theoretically updatable should be updatable by the system as well. Okay, that is auto update, auto updatable or self updatable. Now, whatever the changes I am doing at the view level, okay, whatever the changes I am doing at the view level, you please try to visualize the three layer: view level, या फिर user level, या फिर applicable level. Then comes the logical level, and then at the last comes the physical level, where you have to where you have a database. So if I'm doing some theoretical updates on the user level or the view level, that should be getting reflected at the database. That is called as a auto updatable or self updatable. Okay, that is rule number 6. Then rule number 7 also we have done. It is a relational level operation. Yes, it is a relational level operation, means there must be a insert, deletion, and update operation at each level of relations. Set operation like union, insertion, and minus should also be supported. So that means whatever at whatever level we do the operation, okay, so that should be in the form of a relational algebra, where you can go with the union, intersection, or minus. Okay, so that is called as rule 7, relational level operation. Okay, relational level operation. I think that is the last with what we have done with the rule number 7 in the last lecture. We have to see about rule number 8 now. Am I right? We have to do with the rule number 8, or have we done with rule 8 also? So we have to start with rule 8. Am I right? Ha. So please write down rule 8. Rule 8. Rule 8 is about physical data independence. Now here rule 8, rule 9, rule 10 is about the independency. It is about the independence. So what are these independence? We will see. Physical data independences or independency. Physical data independency. रूल 9 में आएगा लॉजिकल डेटा इंडिपेंडेंसी, और बाद में रूल 10 में आएगा इंटीग्रिटी इंडिपेंडेंसी. सो वी विल सी दिस. राइट डाउन फिजिकल डेटा इंडिपेंडेंसी, राइट डाउन सेंटेंस. The physical storage of data, the physical storage of data should not matter to the system. The physical storage of data should not matter to the system. For example, for example, some file supporting table, some file supporting table is renamed For example, some file supporting table is renamed or moved from one disk to another, it should not affect the application. It should not affect the application. It should not affect the application. I'm repeating, the physical storage of data should not matter to the system. For example, some file supporting table is renamed or moved from one disk to another, it should not affect the application. This is very easy to understand. Take an example of Microsoft Office. Let us take an example of Microsoft Word. Take an example of PDF, or take an example of Microsoft Excel spreadsheet. Now, if you change the name, or if you save these particular files in any of the drive, let be C drive, D drive, anywhere, or if you carry this as a in the pen drive, wherever you open this, your Word should be open in the Word, your PDF should be open in the PDF. I'm talking about the application now. You have to see as an application point of view. Word will be seen in the Word, PDF should be seen in the PDF, and Excel or the spreadsheet should be open in the spreadsheet. Even though you change the name, or even though you store the data in some of the disk or some of the drive. Okay, so that is the physical data independency. So that is the physical data independency, irrespective of the storage location, irrespective of the change in the name. Your data should not alter. Your data should not alter. Okay, your data should not alter. So it should not affect the application. It should not affect the application. That is the meaning of physical data independence. Is it clear to everyone? Rule number 8. Is it clear to everyone? Rule number 8. Okay. Now comes rule number 9. Rule number 9. Rule number 9 is logical data independency. Logical data independence. Logical data independence. Write down. If there is a change in the logical structure, write down. If there is a change in the logical structure, now see here, when I'm talking about the logical structure, it means we are talking about the table. Okay, logical level means tables, rows and columns. You can write down in bracket table structure. If there is a change in the logical structure, bracket will write down table structure, bracket close, of the database, comma, the user view of data should not change. The user view of data should not change. The user view of data should not change. For example, full stop. For example, if a table is split into two tables, try to understand the concept by the example. If a table is split into two tables, comma, a new view should give result. A new view should give result. A new view should give result as the joint of the two tables. As the join of the two tables. As the join of two tables. Now here, logical level will have the table. So for example, if I'm having a table where I'm having four columns. Now this can be split into a table with two column each, with the two column each. Okay. Now when I'm splitting this into two column each, now whatever I'm doing the changes in the main table, that should not be viewed by the user. That should not be viewed as a user. That should not be viewed as a user. Okay, so whatever the changes is happening in that logical level, in the form of change in the table, okay, splitting the table, doing the modification, everything. So that should not be viewed by the user. So that should be applicable only for the logical structure only. So your logical data should be independence. Your logical data should be independence. Okay. So here this is an important, because whenever you do some changes in the logical level, आपके यूजर को पता नहीं होना चाहिए कि the changes has been made, or your the table has been split into two tables. Okay, you should view the holistic view. It should have a holistic view as a single table only. See, these are the queries. Now क्या होता है, when we have a split, whenever the user fires the query, whenever user fires the query, then only, suppose I want the two columns only. So this is a query, so I'll be having the split into this and this. So even though I am having a split, okay, the user should not be able to view this split. Okay, yes, as per the query you should be able to see whatever is required, but the splitting is done at the logical level. Okay, it is done at the logical level. I hope you have understood the rule 9. Shall we proceed further? Rule number 10. Yes. Shall we proceed further? Any question you have, please ask. Am I audible?
Yes, sir.
Shall we proceed?
Yeah, yes.
Okay. So, rule number 10. Now, rule number 10 is about integrity independence. Integrity independence. Independency. Integrity independence. Write down. The database should be able to enforce its own integrity. The database should be able to enforce its own integrity rather than the database should be able to enforce its own integrity rather than using other program. Using other program. Full stop. Integrity when applied at each level. Integrity when applied at each level should not create any problem. Integrity when applied at each level should not create any problem on other level. Integrity when applied at each level should not create any problem on other level. Now, here, what do you mean by integrity independence now? Now, here it means only applies that whenever the database should be able to enforce its own integrity rather than using other program. Okay. Now, here, when you talk about the changes happening at the any of the level, it can be view level, application level, or the logical level, that database should be able to handle that changes at its own level. That means there should be an integrity, there should be an integrity present at each level. Okay, that means if there is a change happening in the logical level, that should not be reflected on the view level. That should be concised over towards that level only. That means there should be an integrity, the integrity at the particular level where modifications are being done. That is a main. Okay, so you can say rule number 8, rule number 9, this collectively is applicable for rule number 10, because it gives you integrity integrity independence. Okay, because at rule number 8 we have talked about the physical, and rule number 9 we have talked about the logical. Okay, or physical logical के ऊपर we have a viewer, or the view level. So view level maybe do not do any changes, because view level is the level where your application program runs. So there we do not do any changes. Whatever the changes is happening is done at the bottom two levels only. So there should be an integrity. There should be an integrity. Okay, when applied at each level, should not create any problem on other level. That is a mean. Okay. So rule number 10 only talks about integrity at level physical and at level logical. That is the meaning. Okay, so this is rule number 10. Then comes rule number 11, second last rule. Second last rule is also important: distribution independence. Distribution, distribution independence or independency. Distribution independence. Write down: in distribution independence, a database should work properly. The database should work properly regardless of its distribution. The database should work properly regardless of its distribution across a network. Regardless of its distribution across a network. Full stop. Even if a database is geographically distributed, even if a database is geographically distributed, comma, with data stored in pieces, क्या लिखा आपने? Even if a database is geographically distributed, comma, with data stored in pieces, comma, the end user should get an impression. The end user should get an impression that it is stored at the same place. That it is stored at the same place. Should get an impression that it is stored at the same place. Now this is important. Sir, can you repeat rule number 11? A database should work properly regardless of its distribution across a network. Full stop. Even if a database is geographically distributed, comma, with data stored in pieces, with data stored in pieces, comma, the end user should get an impression. The end user should get an impression that it is stored at the same place. An impression that it is stored at the same place. That it is stored at the same place. Yes, what does it mean now? Group number rule 11. The rule 11 says the distribution independence. Now, as a user, if you are accessing any database, if you are accessing any database, now this database can be, the database can be available at different locations. I'm talking about geographical locations. This DBMS or database is available at different geographical locations. But if there are some users, user 1, user 2, user 3, these users should not have an impression that these, or they should have an impression that this DBMS database is available at a single store, or it should be available at a single location, even though they are graphically distributed. That is the meaning. Let me take an example of a Google. Whenever you Google search, you may get the data from different locations. But do we get the feel, or do we have an impression that this data is stored at this location, this data is stored at that location? No. Whenever you Google search, you have an impression that data is stored in a single place. Okay, that is the meaning. But if you see at the bottom level, if you see properly at the bottom level, they may be distributed geographically, or the data may be stored in the pieces. बराबर है ना? ये this one piece, this one piece, this one piece and this one piece all combined together to give you this database, DBMS. Okay, this piece available at one location, this also available at other location, this also available at the other location, and this also available at other location. But viewer will never have an impression ki these data is distributed. Okay, that is the meaning. If your database wants to be qualified as RDBMS, then this should follow rule 11, distribution independence. Okay, distribution independence. Is it clear to everyone? Rule 11. Is it clear to rule 11?
Yes, sir.
Now comes rule 12. which is the last rule, which is called as non subversion, non subversion rule, non subversion rule, non subversion rule. Now, what is this non subversion rule? We will see. Write down two sentences on this. If low level access is allowed, if low level, ऐसे लिखो, if low level relational language, if low level relational language is used to access, is used to access a system, access a system, it should not be able to subvert, it should not be able to subvert, 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 या फिर आप लिखो और बायपास, और बायपास, subvert or bypass integrity rules, integrity rules to change the data. आपने क्या लिखा? The low level relational language, if it is used to access a system, it should not be able to subvert or bypass integrity rules to change the data. Integrity rules to change the data. Full stop. This can be achieved by some sort of, this can be achieved by some sort of, by some sort of encryption. This can be achieved by some sort of encryption. This can be achieved, this can be achieved by some sort of encryption. So try to understand what do you mean by non-subversion rule. Now, if you have to do some changes, or there, or if you follow some query, if you use some query to change some data or to get an access, okay. Now, sometimes, if now actually to fire the query, we use SQL in general. But some database, if it is used, if it uses low level relational language other than SQL, other than SQL, if some database uses low level relational language, in that case, that low level relational language should also follow the integrity, should also follow the integrity rule to change the data. That means whatever the rules are applicable for SQL, and if some database is using other than SQL low level language, then that low level language should also follow that integrity rule to change the data. Okay, that means your low level language should not should not void the rule, should not void the rule. That is the meaning. Okay, so whatever the language you used for query, every rule, sorry, the every language should follow the integrity rule to change the data. Okay, that is non subversion rule. Okay, that means you should not bypass or you should not subvert the integrity rules to change the data. Okay, so in short, every language should follow integrity rule. That is the meaning of non subversion rule. Rule number 12. So that is the COTS 12 rules we have studied. Okay, total 13 rules. So you have to by heart these rules. You have to understand these rules with an example. If the question is asked, every rule should be explained with an example. Okay, and whatever the see, this thing I have given, so that mostly, if possible, write down these sentences only. Do not have your own sentences. Okay. During the explanation you can explain with your own sentence, but whatever I have given, that is the rules associated with the rules only. So do not change the words, wording change mat karo. Explanation में wording change करो, no problem. Example में you can change, no problem. But while giving the rules, you have to stick to the same sentences which I have given. Okay, that are the total 13 rules. We can proceed further to understand the next part. Shall we proceed? Shall we proceed to the next topic now?
Yes, sir.
Yes. Now I want everyone to write down the heading: database design. Database design. Database design. Database design. Write down the heading as database design. उसके नीचे लिखो रिलेशनल स्कीमा. रिलेशनल रिलेशनल स्कीमा. रिलेशनल स्कीमा. Write down one sentence about the relational schema. We are talking about the database design. To understand the database design, we should be first able to understand the relational schema, because you know this data, whatever the database we are talking about, that is RDBMS, Relational Database Management System. Okay, so we should know what is a relational schema. So write down sentence on this. It is a logical design. Underline logical. What do you mean by logical? What do you mean by logical? अभी मैंने बताया. What do you mean by logical?
Of my table, sir.
Yes, in the form of table. You're right. It is in the form of table. और रिलेशनल, जब हमने मॉडल पढ़ा था, इफ यू रिमेंबर डिफरेंट टाइप्स ऑफ मॉडल, उसमें भी एक मॉडल था रिलेशनल मॉडल. रिलेशनल मॉडल के डेफिनेशन में भी था कॉलम्स, रोज, टपल्स, एट्रीब्यूट्स, एवरीथिंग. सो रिलेशनल स्कीमा मीन्स व्हाट? It is a logical design. It is a logical design or description of a relation of any database, or description of relation of any database. It is a logical design or description of relation of any database. Full stop. It gives a way of representation of relation. It gives a way of representation of relation. It gives a way of representation of relation. नीचे में एक नोट लिखो, राइट डाउन द नोट. The design of a relational schema decides its goodness. The design of a relational schema decides its goodness. आपका डिजाइन जितना अच्छा होगा, it then it shows that your relational schema, how it is more informative. Okay, जितना डिजाइन अच्छा उतना more informative is your relational schema. Okay, so when you talk about this relational schema, you should be able to understand what should be the logical design. Okay, and in the table we have different attributes, but how these attributes are more related with each other on a specific name of the table. So how, if the relationship is very strong and if these attributes are mentioned in the form of a table, then it gives you a relational schema, a good relational schema. Okay, so here relational schema, if I talk about the database of a student, if I talk about a database of a student, so you have a different attributes. You have a different attributes like name, like roll number, like contact number, okay, like address. Okay, so these attributes should be very closely associated to form a strong relation. As the design is having a good attributes which are closely related with each other, and in that case you will be having a strong or good relational schema. Okay, so relational schema means the attributes which you are consider or under consideration, they should be more related with the entity under consideration, with the entity under consideration. Okay, so here my entity is your student. So the attributes which I have taken, how, these attributes should be very closely associated with the student. Okay, for example, अगर मैंने एक student लिया, sorry, if I have taken the entity of a student, and if I have put up an if I have put up the you know the attribute of suppose the irrelevant attribute. Suppose I have taken irrelevant attribute. Okay, suppose I have taken vehicle. Now this vehicle is about the vehicle which he carries or she carries at college, or whether it is the vehicle which the student is owing. Okay, so this vehicle, if I'm giving an as one of the attribute, but this vehicle is not closely associated, or this is not one of the important property which has to be considered while forming the schema. Okay, this vehicle is not the important attribute, or it is not one of the important properties which has to be considered while forming the schema. Okay, so relational schema, if I have to make a strong relational schema, whatever the attributes you are taking, that gives you the more weightage. If the attributes or the properties are strong, associated with the entity, then your relational schema will be more strong. Okay, that is the meaning of relational schema. Okay, that is the meaning of relational schema. Now here we have to understand there are two approaches. There are two approaches for database design. Okay, so you can just write down two approaches for database design. For database design, so the two approaches are nothing but it is called as a bottom up design. It is called as a bottom up design, bottom up design methodology, which is also called as a design by synthesis. And the next approach is top down approach. Top down डिजाइन methodology. ब्रैकेट में लिखो डिजाइन बाय एनालिसिस. Design by analysis. Design by analysis. Okay, so there are two approaches for database design. First is bottom up design methodology, design by synthesis. Now here if you talk about the first approach, now relationships among attributes are considered as the starting point. जब भी हमको डिजाइन बनाना है, then in that case attributes are taken, and how these attributes are related with each other, how these attributes are related with each other, or how the relationship can be formed amongst these attributes. Okay, and using this we can construct the schema. Using this we can construct the schema. Okay, इसका मतलब है synthesis. Okay, synthesis बोले तो suppose one attribute, this is second attribute, this is ये एक सिंगल एक एट्रीब्यूट है, ये दूसरा एट्रीब्यूट है, ये तीसरा एट्रीब्यूट है, ये थर्ड है, ये फोर्थ है, ये फिफ्थ है, ये सिक्स्थ है. So total six attributes are there. But how these attributes are related, or how the relationship is there between the attributes, if there are relationship between first, second and sixth one, so this first, second and sixth will be taken, first, second and sixth will be taken to form the relational schema. This will be neglected, this will not be considered, this will not be considered. Don't you think that we are synthesizing? पहले को लिया, second को लिया, बाद में छह को लिया. Why first and second and sixth? Because they form a strong relation. There these attributes or these properties will form a strong relationship amongst them to form a to construct or to form a schema. Which schema? Relational schema. To form a relational schema. And why they are not considered? Because they do not form a they if I consider them into the schema, they will be loosely connected. They will be loosely connected. Okay, so that is called as a bottom up design methodology. Okay, synthesis, याद में रखो, synthesis. Okay, now in the top down design methodology में क्या होता है? We starts with the number of grouping of attributes. Number of grouping of attributes. Okay, that means this is called as an analysis. Okay, that means we have this particular groups. We have groups. Suppose this is a group with suppose three columns or a four column table. There is again one entity, a relational model. There is again one relational model with two entities. Okay, so using this 1 2 and 3, using this 1 2 and 3, so number of groupings of attributes to form a relation. Okay, so out of this, how I can first we need to analyze the thing. This table will be analyzed, this table will be analyzed, and this table will be analyzed. Okay, and depending upon that, I can have a one table in which there should be a proper relationship between the attributes and the important one. So using this, that means I have to analyze on this table. I have to analyze on this table. I have to analyze on this table. Once I do the analysis, I will find yes, this and this can be combined together along with this and along with this. Then this 1, 2, 3, and 4 can be combined to make a relationship schema, to construct a relationship schema. Okay, this is called as a top down design methodology. Top down design method. Top down means already we have the different models or a relational model, and using this we are doing the analysis, and then we are making a final relational schema. That is called as doing the analysis and making the schema. That is called as a top down approach. Or bottom up approach, we are doing synthesis. Okay, so the implicit goals of database design is to, this is very important. ये सब क्यों करना है हमको? Why are we doing this? Why are we doing this? To get a database design. Okay, that is the ultimate goal. But why do we have these different two methodologies? The only reason is to reduce redundancy. एक ही डेटा हर बार रिपीट नहीं होना चाहिए, तो रिडंडेंसी सबसे कम से कम लाना चाहिए. टू रिड्यूस दिस रिडंडेंसी एंड प्रिजर्व इंफॉर्मेशन, ये सब इसलिए करना पड़ता है कि रिडंडेंसी ना हो. बिकॉज द डेटा शुड बी स्टोर्ड एट अ मिनिमम स्पेस. अगर रिडंडेंसी ज़्यादा रहेंगी, रिपीटेशन ज़्यादा रहेंगे, द एरिया विल बी ऑक्युपाइड विल बी मोर. Okay, so I have to reduce the redundancy, so the data storage will be available less. The data will be stored at a lesser place, and we can store the data, we can preserve the information. Okay, so these are the two ultimate goals while you have to go with these two different methodologies. Okay, to reduce the redundancy and to preserve the information. Is it clear to everyone? Is it clear to everyone?
Yes, sir.
Okay, so now we will be talking about there are, there are some guidelines to design this relational schema. Okay, there are some guidelines which we have to see while designing the relational schema. So you can write down guidelines to design, guidelines to design relational schema. Guidelines to design relational schema. Okay, will be seeing the guidelines. There are actually four guidelines are there. Okay, so write down. there are four informal भी लिखो, because these are not the set protocols, but these are some informal guidelines. Okay, right down. There are four informal guidelines to design a relational schema. To design a relational schema. And while writing down these four guidelines, try to understand the concept. Okay, so first one, semantics of the attributes must be clear in the schema. Write down. Semantics of the attributes must be clear in the schema. Semantics of the attributes must be clear in the schema. I hope you are understanding this meaning of the semantics of the attributes must be clear in the schema. Okay. So first we will write down these four guidelines, then we will be able to understand one by one. Next, write down reducing redundant information in tuples. 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 Third one, reducing the null values in tuple. Reducing the null values in tuples. Reducing null values in tuples. Reducing null values in tuples. And the last one is disallowing the possibility disallowing the possibility disallowing the possibility disallowing the possibility of generating of generating spurious tuples. Disallowing the possibility of generating spurious tuples. Disallowing the possibility of generating spurious tuples. Now these are the four guidelines which we have to follow to get the strong relational schema. Okay, to get the strong relational schema. So these are the design guidelines, or this is actually this is the informal guidelines which are used to, or which has to be implemented to design a relational schema. So I think we can stop for today. It's too far, and I will be taking this design aspect one by one in the next lecture. अटेंडेंस हो गया क्या, एक बार चेक करो. ईशा इज देयर.
Yes, sir.
अटेंडेंस हो गया क्या?
हाँ सर, प्रियंका मैम आई थी.
आई थी ना, ठीक है ठीक. Okay, we will stop for today. Thank you. If you have any questions, please ask me. Others can leave. Thank you.